Welcome to This Explainer. Today, we're unpacking something truly mind-bending. Picture the Earth spinning in space, totally bathed in energy. Now, what if I told you that a single, ordinary-looking handful of rock holds the hidden power to light up entire cities, or, conversely, destroy them? That is the hidden power of uranium, arguably the most powerful element on Earth. It's an incredible story of science, history, and our future.
Seriously, just imagine an ordinary stone you might find on the ground possessing millions of times more energy than our most common fuels. It sounds like science fiction, right? But it's very real.
So what exactly is it? Well, uranium is a heavy metal found naturally right beneath our feet in rocks and soil. It really doesn't look like much, does it? But on the periodic table, uranium sits all the way up at atomic number 92. Its atoms are absolutely massive, and locked inside those massive atoms lies an incredible, tightly coiled energy just waiting to be released.
Section 1. The science of fission. Let's zoom in to the microscopic level to see exactly how this heavy metal works its magic.
To understand the power, you really have to understand the physics. It all starts with isotopes. You see, natural uranium comes mostly in two flavors. First, you have U-238, which is super common, making up over 99% of natural uranium. But then, you have U-235. This is the rare, fissile hero of our story. It makes up just 0.7% of the element in nature, but it's the exact isotope capable of sustaining a massive chain reaction.
When these U-235 atoms split, they release enormous amounts of energy through a process called nuclear fission. Think of it like a game of microscopic billiards. Imagine a single slow-moving thermal neutron striking the U-235 nucleus. The nucleus absorbs it, becomes totally unstable, and violently splits apart. Boom! In doing so, it releases massive amounts of heat and shoots out 2 or 3 brand new neutrons. These new neutrons then crash into other U-235 atoms, splitting them, releasing more heat and even more neutrons. It's a sustained, self-multiplying chain reaction.
Section 2. Unmatched energy density. Let's see how this builds from a tiny microscopic chain reaction into macroscopic, jaw-dropping power.
The sheer scale of this energy is honestly hard to wrap your head around, but the crucial point is this number, 3 million. Because of the incredible physics of nuclear fission, just 1 kilogram of uranium-235 yields the exact same amount of energy as 3 million kilograms of coal. That level of energy density completely rewrites the rules of power generation. It is millions of times more powerful than burning your standard chemical fuels.
If you try to visualize that extreme scale, comparing human energy use and fossil fuels, uranium literally blows the competition away. When uranium mass converts to radiant thermal energy, literally converting matter into energy, it vastly eclipses traditional fuels like oil or even solar radiation.
Let's anchor this in everyday reality for a second. Think about a single enriched uranium fuel pellet. It's roughly the size of a pencil eraser. That tiny little cylinder produces more heat and electricity than burning an entire ton of coal. Imagine trading a massive dusty train car full of coal for something you could just hold between your thumb and index finger. That is exactly why uranium is considered the most energy-dense fuel on Earth.
Section 3. A double-edged sword. Now, as we all know, an element with this much concentrated power carries enormous historical baggage. It really is the ultimate double-edged sword.
It's crazy to look at how fast things moved. In just 16 years, humanity rapidly leaped from discovering fission in a Berlin laboratory in 1938 to deploying devastating weapons of war in 1945. But then, by 1951, we were generating civilian electricity from fission to light up light bulbs in Idaho. And by 1954, we launched the USS Nautilus, the world's first nuclear-powered submarine capable of traveling underwater for months at a time. It's a staggering timeline of both human ingenuity and destruction.
One of our sources hits the nail on the head, noting, uranium stands as perhaps the most transformative element of the early modern era. The exact same energy that can power peaceful city lights can also be used to cast the dark shadow of a mushroom cloud. This element fundamentally reshaped global geopolitics, requiring strict non-proliferation treaties and heavy international regulations just to balance its incredible energy promise against its existential risks. It is both deeply respected and intensely feared. Section 4. Powering Earth and Space. Today, we're seeing a massive resurgence in respect for this element. As the world desperately seeks scalable, carbon-free power, uranium is stepping back into the spotlight.
When we talk about clean energy, nuclear is already doing so much of the heavy lifting. In the United States alone, nuclear reactors currently provide nearly 45% of all carbon-free electricity, almost half. While wind and solar tend to get a lot of the headlines, uranium is quietly providing reliable, zero-carbon, baseload power day in and day out. It's a massive pillar of our current energy landscape. And its applications are incredibly diverse and growing by the day. Right now, tech giants like Microsoft, Google, and Amazon are actively signing deals for nuclear power to run their massive new artificial intelligence data centers. Why? Because honestly, only nuclear can provide the sheer scale of clean power that AI demands. Over in hospitals, uranium isotopes are absolutely crucial for treating cancers with radiation therapy. And off-world, NASA uses the natural radioactive decay of plutonium, which is actually born from uranium, to keep the Perseverance Mars rover warm and fully charged during those freezing Martian nights.
But wait, it gets even cooler. The Department of Energy and NASA are currently developing something called nuclear thermal propulsion, or NTP. Instead of burning chemical rocket fuel, this system pumps liquid hydrogen right through an incredibly hot uranium reactor core. The hydrogen rapidly expands and shoots out the nozzle, producing incredibly efficient thrust. This technology could safely shoot astronauts to Mars up to 25% faster than traditional chemical rockets, which would drastically reduce their exposure to cosmic radiation in space. How wild is that?
Section 5. Hidden in plain sight. So, we started with a simple, ordinary-looking rock in the ground, and we end up looking at the future of artificial intelligence, human civilization, and deep space exploration.
From the rocks beneath our feet to the energy that lights our world, uranium proves that the most powerful forces often lie hidden in plain sight. It leaves us with a really profound question. How will our collective wisdom manage this extraordinary gift of nature? We have an element that holds the power to either illuminate entire civilizations and carry us to the stars, or extinguish us completely. So, which path will we choose?